All right, question number 10. This one says an acceptable level for insect filth in a certain food is 4 insect fragments, that's larvae, eggs, and body parts, and so on, per 10 grams. A simple random sample of 50 10-gram portions of food item is obtained and results in a sample mean of 4.3 insect fragments per 10 grams. So, kind of gross, but this is a true scenario. We're going to answer parts A through C. So why is this approximately normal? Well, since our sample size is greater than 30, which we have 50, we can assume normal. So the distribution is assumed to be normal. Well, we don't know that until we look at the sample size. The sampling distribution is approximately normal because the sample size is large enough, yes. And if you look at the other ones, they won't fit. What is the mean and standard deviation of the sampling distribution of X bar? So assume the population mean is 4 and the standard deviation is square root of 4. Okay, so since the population mean is 4, and that's also what we assume to be the mean of the sample, so we're assuming the mean is 4. When we talk about the sampling standard deviation, so this sigma of the sample mean was equal to sigma over square root of n, okay? And in this case, we would have square root of 4 over the square root of 50. Since both of them are under square root, I can just do one big square root and just say 4, over 50 underneath one square root. Okay, so let's compute the standard deviation. I'm going to do square root, clear that, 4 divided by 50. All right, we're going to round this to 3 decimal places, so we're going to say 0.283, 0.283. All right, so now that we have this, we want to find the probability that we have a sample mean of greater than 4.3. So we're going to do this with StatCrunch. Stat, calculators, and normal. We want greater than. The mean is 4 from the population mean given right here. Our standard deviation is going to be the 2.83 or the 0.283, and we want to be greater than the 4.3. Okay, so probability to 4 decimal places, 0.1445, and then the 5th one is a 5, so it's going to go up to 6, so 0.1446. So 0.1446. All right, so is this unusual? So this is about 14%. Unusual would be 5% or less than 5%. So since this is 14, it is not unusual. So we got these two explanations. It's not unusual because the probability is large. Not really large, but it's bigger than the 5%. So that's the one we're going to go with. And it says small, but unusual comes when it's small. And 6, what might we conclude? Okay, so we said it was not unusual, so we're still looking at not unusual. So since the result is not unusual, it's reasonable to conclude that the mean is higher than 4, and since it's not unusual, it's not reasonable to conclude the mean is higher than 4. So since it's not unusual, seems like that's a reasonable estimate that the mean is not greater than 4.